Okay, up to our previous lecture, we have studied the some topics. Okay, what are the topics we have studied that I am telling you, so that if you missed that and are not aware what was the topics, then you can continue. Okay, so it is already uploaded and you can go through that video. First of all, the very important thing is naming we have done. Okay, naming when more than one functional groups are there, that we have discussed. Okay, so that is most of the students are not knowing when three COOH groups are there and what to write if you neglect the COH in the main chain. Okay, then most of the students are not knowing about the isomerism shown by. Okay, carboxylic acid shows isomerism with what other functional group. Okay, then position isomerism and structure and hybridization. Okay, structure and hybridization we have done in our previous lecture, and most important thing we have done is classification on different bases. Okay, so up to here we have completed in our previous lecture. Now it's time for the next lecture. Okay, next slide we are going to now. Okay, so before that, I hope all of you are started noting down. Okay, make proper notes. Okay, otherwise you can do one thing. You can first understand, after that take screenshot of each and everything, then you can start making the notes. Okay, and questions we are doing nowadays with the questions, topic plus question. Okay, so today's our topic intention is to complete the preparation methods. Okay, so by the oxidation of alcohols, aldehyde and ketone. So for the alcohols, again there will be three types of alcohol. Again there will be how many types of alcohol? There will be three types of alcohol: 1 degree, 2 degree, and 3 degree. Okay, and the best part of the alcohol which is required for conversion into carboxylic acid is 1 degree alcohol. Okay, so there is a in the alcohol we have seen, in the alcohol ease of, okay, ease of oxidation, ease of oxidation will be easily oxidized will be 1 degree, then difficultly oxidized will be 2 degree, then very difficult will be 3 degree. Okay, so when you wanted to select alcohol, then you can select the, for oxidation the best alcohol is what? 1 degree alcohol. See here also we are checking the same, and to the corresponding carboxylic acid. Why we prefer that? No loss of the carbon. Okay, if the alcohol contains 5 carbon, then you will get pentanoic acid. What you will get? Pentanoic acid. So with the mechanism or memory understanding, I will tell you, so that you should not feel any difficulty in organic. Okay, organic is made easy with the simple explanation. So first oxidation means removal of hydrogen. First oxidation means you will provide oxygen, and what it will take, it will remove this oxide hydrogen. Then what it will form? RC double bond O and hydrogen. See, this type of animated explanation will be easy to understand. If you try to understand from the books, then it will be difficult. Okay, and whenever you have a doubt, you can ask in the comment section. Okay, so RC double bond OH. Then further, if you add oxygen, that will go and insert itself here. So what it will form? RC double bond O OH. So this is what the functional group RCOOH. I think first thing is understood. So nowhere here you find nowhere carbon is lost. Okay, that is the advantage of that. Okay, so no carbon is wasted, therefore this is the best method to 1 degree alcohol. Why they are preferring 1 degree alcohol? Now I think it is clear to all of you. Okay, now let's see the next one. Let's see the next word, aldehyde. So everything is already informed to you. First we have done alcohol, then we are going to do for the aldehyde. Okay, so for alcohol, what are the oxidizing agent we are going to use? KMNO4 strong oxidizing agent, K2Cr2O7, strong oxidizing agent. And for K2Cr2O7, one limitation is that it can act as a oxidizing agent in acidic medium only. Which medium? Acidic medium. And some students feel very difficult when they write like this, MnO4 oblique H positive. That means they wanted to oxidize in place of the acidic medium. Every reagent requires something for a medium. Okay, suppose you wanted to get into the BTech or medical, you are taking somebody is comfortable with Hindi medium, somebody comfortable with Telugu medium, somebody comfortable with English medium. So like that, KMNO4 is comfortable with the acidic medium. Even though it can oxidize in all medium, OH also no problem, H2O also no problem. This is alkaline, this is neutral. Understood? It can oxidize in all medium, but the best method is to use acidic medium. But K2Cr2 is not like that. It can explain or it can oxidize only in acidic medium. Okay? So this is about the limitations of the K2Cr2O7 and the reagent with medium. Okay? Now if we take the aldehyde and ketone, the best part out of the aldehyde and ketone is aldehyde. Again, the same thing is because loss of hydrogen, loss of carbon will not be there. Okay. So here itself I will write, actually this is the structure of the aldehyde. This is aldehyde. Now the acidic K2Cr2O7 will provide the oxygen that will go and here. Okay. Now what it will form? RC double bond OH it is formed. Okay. So is there any loss here? No loss of carbon. Wherever there is no loss of carbon, that is the best method, easiest method, applicable method. Okay. See, but problem is with the ketones. Okay. First of all, the acid will be mixed. You will not get one acid, you will get two acids. How many acids you will get? Two acids. And that also one problem is that lesser number of carbon atom than the ketone. Why? Because see, there are two parts. So this oxygen will go and break this one. Okay. So after breaking this one, the acidic medium hydrogen and this oxygen will be converted into, this is the part it is giving this one, and R dash CH2, R dash CH2. I will use the other color. Which color you prefer? Pink, red? Okay, red. So this red color line shows the R's. This is R dash and this carbon is converted to COOH. Okay. So because of that there is a problem. Breaking will be requiring high temperature and pressure, drastic condition. In the exam what they will use? Drastic condition. Okay. So what are drastic condition? They are the high temperature and pressure. And the one more problem is that it will give you the mixture of acid, and one more problem is that lesser number of carbon. Okay. So the best way is to use aldehyde out of the carbonyl compound. Okay. Now for this example, here R dash is what? CH3 and R is what? Again CH3. This C is common. So it will break like this. Okay. This CH3 will be converted into HCOOH, and this part from here to here, if you feel that it is very clumsy, I will draw it separately. Okay. Don't hesitate to ask me anything. Okay. Okay, here this carbon will be attached here. Understood? So this is 2 carbon. This carboxylic acid is of the 2 carbon, lesser than the, it was having how many carbon atoms? 3 carbon. But it is having only 2 carbon. It was having 3 carbon, but it is having only 1 carbon. This is the meaning of this lesser number. Lesser number. Okay. And problem is that formic acid is very unstable, and it will further get oxidized to form CO2 and H2O, to form CO2 and H2O. Okay. So R dash, here R dash is CH3. That also I will tell you. See, if you have any doubt, if you ask, then immediately I will tell. Okay. So this is the CH3 now. Understood? This R dash is CH3. So this already hydrogen is there. When you provide the sufficient oxygen, when you provide the sufficient oxygen, first of all, it will take out this hydrogen as H2O. Then what it will form? H and OH. Okay, and after that this will be removed and C double bond O will be formed. As there is only one hydrogen, therefore it will be HCOOH. Okay, so this is about the aldehyde and ketone. I think it is clear to all of you now. If you have any doubt, you can ask. Otherwise, we will go to the next slide. Before going further, I want that you should have a clarity. 1 degree alcohol, how many steps? 2 steps. Okay, then it will give the carboxylic acid pure. There will be no mixture here. Okay, and if it is a 2 degree, sorry, here it should be 1 degree alcohol. Okay, 1 degree alcohol is the, this is the 1 degree alcohol. And another thing is, if you use the aldehyde, it will takes place only in one step. Okay, and here also it will give you the carboxylic acid, and that is going to be pure again. Understood? If we take the ketone, if we take the what? Ketone, then it will take only one step, but problem is that it will give the mixture of carboxylic acid with the lesser number. Okay, so this is important for the conversions, where it is important for conversions. Okay, convergence, it is important. I think all of you noted now. Let us see the next part. Okay. Okay, next is from the hydrolysis of cyanide. Cyanide is a common name. IUPAC name is nitrile, ILE. Okay. In organic chemistry, you have to be very, very particular about this. Nitrile, ILE is CN. Okay. And cyanides on complete hydrolysis. There are two types of hydrolysis. Okay. Up to here it is called as a partial hydrolysis. You have to be very word with the hydrolysis. Like complete combustion is different, partial combustion is different. Same way hydrolysis, complete hydrolysis is different, and partial hydrolysis is different. Okay. So here it is partial hydrolysis will give, because again we will study in the preparation of amides, where you will study up to here in the amides. This is amide functional group. What is the functional group here? Amide is produced. Okay. Again, you will use one more water molecule. Then we are getting the carboxylic acid. So cyanides on 2 times hydrolysis. How many times? 2 times. If you hydrolyze only once, you will get the amide. But if you hydrolyze 2 times, then only you will get the carboxylic acid. Now let us see the mechanism part on the whiteboard. Okay. So is the whiteboard displayed to you all? Okay. Now R C triple bond N. Is that whiteboard displayed, and whatever I am writing, I think all of you are able to see now? Yes or no? Okay, sir. Okay. So RCN. RCN is the triple bond. Okay. Now hydrolysis. Hydrolysis, what you will write? H and OH. In H and OH, which is minus, which is plus? OH minus is minus, H will be plus. Okay. Out of this is a sigma bond, is very strong bond. This is pi bond, this is pi bond. So let us suppose this pi bond will break, and that electron will go to which element? Question is that this electron will go to carbon or nitrogen. That electron of pi bond will go to carbon or nitrogen? Answer fast. Answer fast. So here this electron going only, which bond will break and why it will break, that all reason if you know, then in future you can write your own mechanism. Okay. So this pi bond electron will go to nitrogen. Pi bond electron will go to nitrogen. Okay. Because nitrogen is more electronegative. Carbon is less electronegative. Always electrons are pulled by the more electronegative. Okay. So once it is electron is gained by the nitrogen, then nitrogen will get dash charge negative. Carbon will get dash charge positive. So our OH will go to where? Carbon. And hydrogen will go to where? Hydrogen, nitrogen. Okay. So after all this happened, can you understand from the book this process? No. That is why people who are studying in the book are not able to understand. Okay. So this is the answer will be OH. Why it is going, where it is going, all will be explained here. Understood? Now after this there will be tautomerism. Okay, metamerism, tautomerism. So then what happens? This hydrogen will come here, this hydrogen will go here. Okay, so then it will be RC double bond O and single bond NH2. Now we got what? Amide. What we got? Amide we got. Okay, now next what we will do? We will again hydrolyze H and OH. Okay, so this nitrogen is minus, this hydrogen is plus. So this hydrogen will go here and OH will attach like this here. Okay. So then RC double bond OH, then NH3 will come out. Okay. So ultimately what we got it here? Carboxylic acid we got it. We got it or not? Yes, sir. Okay, now whatever I told you on the whiteboard is this one. Understood? So now I think it is very clear. So we want both of them. We want board use also. We wanted printed notes also. Okay. So then from hydrolysis of acid derivatives. Okay. And the best question is what is acid derivative, sir? Okay. So acid derivative, basically acid is RCOOH is acid. Okay. In that what I will do, I will erase OH. What I will do, I will erase OH. In that place, I will write something beautiful, other group. Okay. So after replacing with the other group, whatever I got it, it is all because of what? Carboxylic acid only. That's why this is called as a acid derivative. From where whatever the thing it is provided. Okay, so that is called as the derivative. So we got it all just because of the carboxylic acid. That's why it is called as a acid derivative. Okay, now here I am writing so many part can be available. Okay, what are that part? I am writing it here so that everything must be understood here itself. Z can be halogen. That time it is called as a acid halide. What they are called as? Acid halide, RCOX. Suppose Z here in place of the Z, if it is NH2, then it is called as acid amide. What it is called as? Acid amide. And in place of the Z, if it is OR dash. Okay. So then it is called as a ester. What it is called as? Ester. And in place of the Z, if it is O, C double bond O, OR dash, then it is called as a acid anhydride. So how many derivatives are there? Acid anhydride. Okay. Anhydride, HYDRID. Okay. So total 4 acid derivatives are there. Acid halide, acid amide, ester and acid anhydride. These are the total how many derivatives? 4 derivative. In that, what I am doing, just I am commonly representing as RCOZ. Okay, is that clear to all of you? Suppose if I write here CH3, CH2, C double bond O, and it is O, C double bond O, CH2, CH3. Okay, what is this functional group name and what is Z here? Okay, two questions are there. What is the functional group name and what is the Z here according to previous indication denoting? Okay, so like that, as per our representation, this is Z and functional group name is acid anhydride. What it is? It is called as a acid anhydride. Okay, and the Z here, it will be, this part will be Z. Okay, because up to here I told you R C double bond O Z. So up to here you should keep it, and rest all you will take it as a Z value. Is it understood? Now is it clear? Okay, so this is about the question about the representation. Now we will go back to our slide program. Okay, so acid anhydride is a part of the derivative of our carboxylic acid. Okay, carboxylic acids have how many derivatives? Acid halide, ester, amide, and acid anhydride. 4 derivatives are there. Okay, so let's see one by one. When you hydrolyze them, when you add water to them, so here X can be any halogen, preferably it is chlorine. What is here? It is chlorine. So on HOH, water should be written as HOH. Okay. Now question is, with the Cl, who will go? H will go or OH will go? Okay, the organic will be better when you ask yourself, why only this? Then your organic is going to be tremendous. Okay, so I will show you and I will tell you the reason. See, Cl is minus, hydrogen is plus, OH will be minus. So opposite poles attract each other according to the physics. Okay, so here on this what happens? Okay, on this what happens? This HCl will be removed. Okay, so once Cl is removed, our OH will go attach here itself. Understood? So this is what the problem is. Okay, so this is answer. I think it is clear to all of you. RC double bond OH plus HCl. Now next process is by the hydrolysis of acid anhydride. Actually, anhydride means anything which is formed by loss of water. So again, when you give back its water, so suppose this hydrogen goes here, this OH will go here. So this is also RCOOH and this is also RCOOH. So how many moles of RCOH is produced? 2 moles of RCOH will be produced. Okay. So total 4, what do you call, acid derivatives are there. Out of them we have studied how many? 2 we have studied. In first one we got HCl and carboxylic acid. In second one we got both moles of carboxylic acid only. Okay, up to whatever we have preparation done, based on that immediately you should do questions, then only your perfect practice will be there. Okay, now you have to write the IUPAC name of the X and Y. Okay, CH3, CH2, CN, hydrolyzed with 1 mole of water, then hydrolyzed with another mole of water. What is the IUPAC name of X and what is the IUPAC name of Y? That is our question. Okay, see here, now I will tell you, just understand the how to solve this type of questions. Okay, so just now I told you with the mechanism, only thing here R is changed, RC triple bond N. Okay, in that what I told you, water should be written as H and OH. So H will go to N, OH will go to C. So then it will be CH3, CH2, C, it will be OH, and it will be double bond NH. Now after that, what mechanism I told you? Tautomerism. This pi bond will go here and hydrogen will come here. So CH3, CH2, C double bond O, NH2. So our X is this one, okay? And what is its name? Its name is propanamide. Three carbons are there. So X is propanamide. Propanamide. Okay. Now when you further use the water molecule H and OH, so this OH will be attached here. H and NH2 will be lost as a minus NH3. Then it will be CH3, CH2, C double bond O, OH. Is that understood? Any doubt about this? If you got any doubt, you can ask. Otherwise, let's proceed to next question. Okay, are you ready for the next question? Okay, next, butanoyl chloride. Butanoyl chloride on hydrolysis gives H3O plus they will give. Okay, what they will give? They will give just H3O plus and find X. Okay. Now let's see who will answer fast. Okay, suppose they give Y also and Y they have given like gas. X and Y you have to find out. See here, very simple. Butanoyl, OYL means the functional group is acid chloride. CH3, CH2, CH2 and C double bond OCl. This is butanoyl chloride. Okay. So when it is added with water, H3O plus means acidic hydrolysis. Okay. What it is? Acidic hydrolysis. So this HCl will be removed and OH will be attached. So product will be CH3, CH2, CH2, C double bond OH. Okay. Then what else it will form? HCl it will form. It will form HCl. Therefore, Y will be gas and its name is butanoic acid. Okay, what is this? Butanoic acid. Simple. Okay. X is butanoic acid, Y is HCl gas. Now I think it is clear to all of you now. Okay, butanoic acid, not ethanoic acid. Okay. Okay, now let's see the next one. Now here in this question you are given with product, you have to find out the reactant. We want 2-methyl hexanoic acid. For that what should be the X value, what should be the Y value. Okay. That IUPAC name you write, then it is sufficient. Okay. Okay, see here, hexanoic acid. What is our product? Hexanoic acid with one hydrolysis. Okay, with what? One hydrolysis. Okay, now listen here. This is just reverse of the what they ask. Normally, you will find the question with reactant given and product you have to find out. But you are given with product and you have to find out the reactant. Okay. So here H3O plus means it is acid hydrolysis. So first let us write the product structure. So this is a 5 carbon, 6 carbon and 6th carbon will have the COOH and it is the methyl group. So try to go for the reverse mechanism also. So don't be waste your time just because of the old methods, old questions. So this type of question also will come and are coming also. Okay. So this is hexanoic acid and before hydrolysis this will be amide. What it is going to be? Amide. Then only on hydrolysis it will give you the hexanoic acid. Okay. So this will be CH3, CH2, 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 4 carbon, 5 carbon and 6th carbon will be like this. So and it is supposed to be one hydrogen is supposed to be what? One hydrogen is supposed to be CH3. Okay. So what is its name? 2-methyl. Name also I am writing very carefully. Note down. 2-methyl hexanamide. What is this? Hexanamide. Okay. 2-methyl hexanamide is answer. Now here before that this will be completely removed. Therefore it will be reactant will be like this: CH3, CH2, 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 CH and CH3. This will be C triple bond N. Okay. So this will be 2-methyl. This will be 2-methyl hexane nitrile. Okay. Hexane nitrile. Okay. This is the answer. I think all of you understood now. Okay, after solving the questions related to up to that topic, now we are into the next hydrolysis. As I told you, total 4 acid derivatives are there. This is the second acid derivative, acid anhydride. This already I told you. So this H and OH will be there, 2 moles of carboxylic acid. And very important note, formic acid cannot be prepared. Formic acid cannot be prepared by these two reactions. Okay, because it is corresponding formyl chloride, formic anhydride are unstable product. Okay, so first of all, what it should form? HCO NH2 it should form. Okay, then it should form HCOOH. So this cannot be used. Okay, HCO, we want to get this. First of all, we should use HCOCl. This is unstable. And HCOOCOH. This is also unstable. This is also unstable. Once reactant itself are unstable, then they are not giving the product. Okay. Next, from carboxylic ester. So this is ester. Okay. So this is well-known reaction, Fischer's fire reaction. What it is called as Fischer's fire reaction. On this OR dash hydrogen will be going and it will form as a alcohol, and on this OH will be going, then it will form the carboxylic acid. Okay, hydrolysis of ester is possible in both medium, acidic medium also no problem, and basic medium also no problem. This is about the third preparation method. Okay, from the acid derivatives. Okay, so next this is the mechanism. So once you carried out the reaction in acidic medium H plus, okay, so first of all this water it will go and react. This is the total reaction in presence of H plus. It will give you the carboxylic acid and it will give you the ester. So always you should remember the oxygen. This oxygen will go with the alcohol. This is very important. Okay. Now first let us see what is the mechanism. So this H plus will go and attack with the carbonyl oxygen. Okay. Now this will be positive now. So this will be leaving group. This pi bond will come here and that negative. So this carbon will be positive. So this carbon positive, now our water molecule will react with this to form H3, H2O will be attached here. This H plus will be lost. But here single carbon holding two oxygen is highly impossible. So what it will do immediately, it will go away with the neighboring alcohol RO as a ROH. Okay. So then R dash OH is there, then this will be positive. So now it is a time to give back its hydrogen. So H plus is only presence is there. That's why RCOOH will be formed. Okay. Now I think it is clear now. Let's see the whiteboard also. Okay. So that practically writing is different. Okay. So I will be asking you, just now I have explained. So you are understanding or not, I will come to know. First of all, RC double bond OOH. When I write in acidic medium, so in the acidic medium where it will go, It will attack on which carbon, which oxygen. Okay. Answer should be, sir, carbonyl oxygen, sir. What should be your answer? Your answer must be carbonyl oxygen, sir. It will straight away go here. Okay. So first step will be like this. R, C, single double bond oxygen, and here hydrogen. Oxygen will carry the positive charge. Okay. And this is OH as it is I am writing. But after a certain time, oxygen cannot carry the positive charge because by birth it is electronegative element. It feels very difficult to carry the positive charge. So then what it will do? This positive charge will be carried by this carbon. Okay. So then it will be Rc positive, and this will be single bond OH. This will be single bond OH. Okay. Now what it will do next, our H2O. Okay, what will be the next part? H2O. Sorry, here this is erased. Okay. So here next step will be our, this is the, sorry, R dash. It will be R dash. Okay. It will be R dash. Ester we have taken. Okay. So now it will be H and OH. So H and OH will be R, C, both side it will be OH and OH. This will be OR dash. I will take it as a OR dash. Okay. Now this is unstable because it cannot carry both OH. Then this will go along with this. Then it will be ROH, and this will be O negative. This will be R dash OH. Okay. So now it will react with water molecule and loses this. This hydrogen is to be lost. Okay. Then it will form RC double bond OH. Okay. And already R dash OH is already there. R dash OH is already there. That extra H plus will be lost over here. Okay. So this is the mechanism. I think it is clear now, or you can see once again that slide. Okay. So wherever you are comfortable, you can understand with that. See, this is the comfortable position. If you are understanding this, you can go with this one. Okay. So first what it will form, H plus attack and carbonium ion. And carbonium ion, first actually oxygen will be positive, then carbonium ion. Then H2O will attack here, H2O will be attacked here. Okay. Then H plus will be lost. Sorry, I think there I have done a mistake. Here I have not taken this complete H2O. Okay. So this will be complete H2O. This I am correcting just now. Okay, this complete H2O will be attached here, then H plus will be lost. Only there it was a mistake, otherwise everything is fine. Okay. So this is the complete mechanism. You can make a note of it. Acidic medium mechanism, I think clear now, both ways. Now let's see the next one. Hydrolysis in basic medium. There it was started by the H plus. Now here it will be started by the OH minus because it is basic medium. Okay. So in basic medium, OH minus will be initiated. So it will be SNAE, nucleophilic substitution and addition elimination. Okay. So here OH minus will always remember this oxygen will be with alcohol. Okay. So here OH minus will be available. So in presence of OH minus, let us take this electron will be here and this will be positive. So OH minus is attached here. Then this is formed and R dash. Okay. Then after that, that hydrogen will be as it is. This R dash and O is removed as a OR dash. Sorry, up to here. Okay. So this oxygen will be, this bond will be donated here, and up to OR dash it is minus. Okay. So our OR dash is here, then RCOOH. This will become as a C. This part has become as a RCOOH. Now this will be RO dash. It will take the H plus from R, then it will form as a R dash OH. Where it is basic medium is very simple. First is substitution of nucleophile. Which nucleophile? OH minus. Then after that addition of OR minus. Then elimination of R dash OH. Okay. So this is about the hydrolysis mechanism in both acidic medium and basic medium. Okay. I think it is clear now. Okay. Next preparation method is by alkaline hydrolysis of alkylidine trihalides. Trihalide means three halogen must be there and all of them must be on the last carbon only. Okay. So very simple. This 4 potassium will be removing the 3 KCl and 1 potassium will be attached here. So this is a potassium salt of carboxylic acid. So when it is treated with the dilute acid, then this hydrogen will be substituted here, then RCOOH and KCl. Okay. Then very important reaction, this will be used in the ascent series. What series? Ascent series. Ascent series means when you have to increase the number of carbon atom by 1. Okay. So formic acid cannot be prepared because already 1 carbon is here, 1 carbon is here. Okay. So this mechanism I will tell you, so try to understand now. Okay. So mechanism is very, very important in the organic that you will come to know only when you write on your own. So here R, and every time you should ask why it is like this. So R mgx plus CO2 I will write like this. Okay. Now here which bond will break? If you question yourself which bond will break? Answer should be pi bond will break because it is weaker. So it will go to which side? It will go to oxygen because oxygen is more electronegative. So this will get negative, this will get positive. And in RMGX, magnesium being the metal, it will be positive. R being the carbon non-metal, negative. Okay. So this R will go to negative, will go to positive, positive will go to negative. Okay. So the product will be like this. R, C, double bond will be converted as a single bond. On that single bond, MgX is attached and C double bond. Okay. Up to here, why and where, everything is clear now. Now, if I add H and OH, okay, so where H will go and where OH will go. Here this is negative, this is positive, and here it is negative, here it is positive. So this OH and this MgX both will be removed as a MgOHX. So then answer will be RCOH, C double bond O. So this is what answer is. Okay. Carboxylic acid, we got it. We got what? Carboxylic acid. But here only R is there, but here one extra carbon is attached. Which carbon? This is of the carboxylic acid, carbon dioxide carbon. Okay. So here if N carbons are there, here it will be N plus 1 carbon. Whenever you wanted to increase the number of carbon by 1, then this method is highly suitable. Okay. Note down this mechanism.